This is video 1 about gas laws. The gas law being used in this problem is the ideal gas law and is a combination of Gay-Lussac's law involving pressure and temperature, as well as Boyle's law that involves pressure and volume. The independent variables are temperature and volume, and the dependent variable is the pressure. The constants are the mole value of the substance and the universal gas constant, or R, depending on which unit of measurement the pressure is taken. Through the use of proportions, you can determine that the new pressure of a gas whose temperature is tripled and the volume doubled would be 2/3 of the original pressure. The pressure could not have been 1/6 because the proportions wouldn't create that small of a ratio, and 5 times the original pressure would be much too high. It also couldn't be a ratio of 3/2 because in that case the numerator and denominator had been switched. So this problem uses the ideal gas law as well and can be written as 748 milligrams of mercury times 50 liters over the product of 297 Kelvin, which is the converted 24 Celsius, times 62.36 units of universal gas constant, and the mole value represented by the variable N. When comparing the two problems, the only independent variable is the type of element being used, in this case argon and diatomic nitrogen. The dependent variable would be the mole value and the constants would be the pressure, volume, temperature, and universal gas constant. To answer the question, the ratio of the two could not be twice or half as much as the other, and instead the number of moles would be the same when using the ideal gas law, because the ratios are not altered by what gas is being used. This is an example of Avogadro's law, which states that the equal volumes of all gases at the same temperature and pressure have the same number of molecules. These figures display Avogadro's law and how it relates to volume and mole count. The independent values in this case are volume and moles, and the dependent is respectively the pressure. The constants in terms of ideal gas law would be the temperature and universal gas constant. To order the samples in increasing values of pressure, sample 2 would be the lowest due to its increased volume and decreased mole count. Samples 1 and 4 would have higher pressures due to sample 1's decreased volume but also decreased mole count, and sample 4's increased mole count but also increased volume. Finally, sample 3 would have the highest pressure because of its low volume and high mole count.